and disregard the external NAT IPs. Okay, so you will be, and in fact, in the lab, it's going to have you disable NAT here. Then it's going to have you go into the NAT policy and actually create another rule where it's not going to do any address translation, but between the networks. Okay, so it's kind of like belt and suspenders there, I guess. Okay, so that's the mesh community. We'll take, where is the star community? Well, again, we're in our VPN communities here, so we have to come up here to the sunburst, the new icon here. And so you could set up another mesh community here. We'll take a quick look at the star community, because it is just a little bit different, all right? With the star community, again, a lot of these items are the exact same thing as on the mesh community. But you'll notice here under gateways, it says center gateway and satellite gateways. Okay, sometimes this is called a hub and spoke. It's kind of like a wagon wheel or a bicycle tire or something like that. You got a center gateway here. And since Alpha is our headquarters, you know, that would probably be our center gateway. The satellite gateways would be Bravo and Charlie and Delta. You know, it'd be our remote sites would be the satellite gateways, all right? Otherwise, encrypted traffic, encryption, tunnel management are the same. What's different now here is the VPN routing. So VPN routing, if this is Alpha, our Alpha firewalls. This is Bravo, Charlie, and Delta here. Our satellites, our remote offices. By default, the VPN routing is only between the satellite and the center gateway. Okay, so Delta here could have encrypted traffic into Alpha back and forth, but it couldn't get out to Bravo or Charlie or whatever these others are that way. Now, if we did want to allow that traffic, we could come in here and we could select to center and to other satellites through the center. So now this is Bravo, and this is Delta. Now Delta can have encrypted traffic with Bravo up here and vice versa, but they have to go through the center gateways first, all right? Your third option would be to the center, through the center to other satellites, to the internet and other VPN targets. So now we've got Delta. Delta is part of our, our mesh community that we're setting up here, for example. Delta is also included in a couple other VPN communities. And so now, depending on Delta's policy, then Delta wants to participate in one of those other VPNs. So first it has to come in through the center, and then from that point it's allowed to go on out to other VPN targets, or even out to the internet. All right, and this is kind of similar to the way my work computer has always been. Like I said, I worked from home for 9 years. With my bank laptops and my other HP and Dell laptops that I had, I was never allowed just on my business laptop just to browse out to the internet. I was never allowed to do that. I always had to VPN into the, in through the gateway, into the internal network. Then I could browse out to the internet. I'd go through through the proxy server, and then I could get on out to the internet then. So that's kind of what the way this is. I could go out to the internet, but I had to go through the center first, and then I was allowed to go on out. The multiple entry points. This says choose the method by which the entry point gateway will be chosen from the gateway in the center. So select the closest gateway source, the closest gateway to the destination. Random selection, or manually set a priority list. Multiple entry points it just means, and again, I'll just kind of give an example of me working from home. I said we had our entry points in Virginia, one over here in Dallas, and one out in San Francisco. So of course I VPN'd into the one here in Dallas. I just had a Cisco AnyConnect, that we used for that, and so that's what I would ordinarily do. Every once in a while, it only happened a couple of times in all the years, but there were a couple of times where I couldn't get into the Dallas for some reason, and so So I had a choice between going to Virginia or going to California. And normally I would choose California to San Francisco because I was an hour behind all the East Coast people that were already logging in through Virginia. So I would just go out to San Francisco then and log in through there until my Dallas came up. So that's kind of an example of multiple entry points. Otherwise, all the rest of these are the same down here. And in the lab, you'll be setting up the meshed My Internet there. Yeah. So that'll give you some idea. Again, when we're going through the slides, it's going to reference some of those things there, and now you'll know where that is. Again, on the VPN, we'll just take a look at this real quick. When you're setting up your VPN rule, we've been looking at the rule number, the name, source, destination, service, action, track, install on. We've been looking at all these things. We've been totally ignoring the VPN. So with the VPN, if you right click on it, it has some different options here for all connections, clear or encrypted, all site-to-site VPN communities, or for specific VPN communities. You'll be setting up a specific VPN community. If I select that, then this has the VPN communities that you've set up here. So you'll be selecting the My Internet there. If I select the all connections, clear or encrypted, it just goes back to any. All right. The all site to site. This would be all gateway to gateway. So again, if this includes multiple VPNs, you would set up all gateway to gateway or all site to site VPNs. Okay. Okay. So let's take a look at the slides now, and then we'll get into the lab. So now we're going into, should be chapter 6, right? Yeah, chapter 6, basic concepts of VPN. So this says, the learning objectives understand site-to-site and remote access VPN deployments. We don't really get into remote access here. In CCSE on Wednesday, we do set up an SSL VPN from Bravo over to Alpha, a lot like a remote user would do, and it's a fun lab that we do. But today we're just concentrating on the site-to-site VPN between Alpha and Bravo. How to analyze and interpret the VPN tunnel traffic. Again, you'll be opening up the B host. You'll be FTPing over to the ALDAP server, the 11.101. You log in as admin, the checkpoint password. You can just run a PWD or whatever, close that out. Then you'll come back over and, well, you're still in. You'll come back over to Alpha, open up the logs, and you can just filter on VPN, and it'll remove all the other logs. And what you'll see is the encryption coming out of the B gateway. You'll see the key exchanges. Then you'll see the decrypt on the Alpha gateways there. So again, very basic checkpoint VPN. This starts kind of, introduction to virtual private networks. Like most people don't know what VPN is or something. By now, everybody's pretty familiar with VPN. It always, in the illustrations, it always looks like there's a kind of a plexiglass tunnel coming through here that all our packets are going to go through. But what we're doing is we're just, like I say, we're hashing that information, and then we're encapsulating that packet, all right, with the encryption there. So as it's going through the tunnel, it's still all the different packets and everything that are going through the internet, but now that they're hashed, they're encapsulated, encrypted, and so again, if there's a man in the middle trying to get something, then it's going to be very unlikely they'll be able to open that up and see what that information is. But we'll go through some of the terminology in a couple more slides. So IPsec VPN. IPsec is a suite of protocols to manage encrypted communication tunnels. IKE, IKE is Internet Key Exchange, of course, and that's going to create the VPN tunnels. It manages the keys used to encrypt and decrypt the data and information. So again, what we're doing here between Alpha and Bravo, or between your company and another company that you're trying to set up an encrypted connectivity with, is that you're trying to set up if it's a symmetric cryptographic system, but what you're trying to do is to come up with the exact same key on both sides, right? If you're sending traffic out of the gateway, you'll use the key to encrypt that traffic. As it hits the peer gateway, they're going to have the exact same key to decrypt it. And when they're sending stuff back, they'll use that key to encrypt. We'll use the exact same key to decrypt it. All right. So that's what we're doing when we're setting up the two different phases of IKE to do that. IPsec uses the following for authenticating and encrypting IP packets for secure VPN communications. AH is authentication headers. Authentication headers, that's authenticating the IP header. Again, you've got the integrity of your connections that going through the tunnel. Make sure the payload hasn't been changed since the transmissions as it's going across the internet. The ESP, this is your encapsulating security payload, and this operates directly on top of IP. Again, origin, authenticity, integrity. This is encapsulating the packets as they're going through the internet. And then SA, those are your security associations. You can manage which resources can communicate per the security policy. All right, and again, as we're going through the two different phases of IPsec and IKE, remember it showed that with the first phase, we're setting up the IKE Security Association, and in the second phase, we're setting up the IPsec Security Association, and ultimately the encryption. Okay, so IKE conducts a two-phase negotiation process, phase 1 and phase 2. Phase 1 is called main mode. Phase 2 is called quick mode. All right, this is the hard and heavy work here in phase 1. This is where we're going to set up our encryption algorithms. And when we looked at the community there, we saw what our different options were for the encryption algorithms and the hash algorithms, the authentication method, certificates or shared secret, and which Diffie-Hellman group. Oh, I didn't actually drop that down, but you can. It'll tell you to set up a Diffie-Hellman group of 19 when you're setting up that encryption on there. All right, on for your community. There are different Diffie-Hellman groups. There's 1, 2, and 5 are using 768-bit, 1024-bit, 1536-bit. Those we normally avoid those Diffie-Hellman groups. They're just there's just not adequate security anymore. Normally, group 14 for 2048 bits. That's your minimum acceptable. There's also a group 19 and a group 20 for 256 and 384-bit elliptic curve. And so that's normally what, especially when you're using Cisco, I think they use if I remember right, they used the group 19 quite a bit. The encryption algorithm, again, what we're doing here is we're trying to build these keys, right? Each side, for the Diffie-Hellman keys, or the Diffie-Hellman, the key exchange, you've got a private key, your private encryption key, and then you've got a public key. And the other side has their own private key and their own public key. So when you do the key exchanges, you're exchanging, you're retaining your own private keys, but you're exchanging the public keys. All right. So now you've got your private key and the peer's public key. That they've got your public key and their private key, and then as you agree on the same encryption algorithm, hash algorithms, authentication methods, and all that. As you're developing all these things, then you're going to complete IKE phase 1 here with the IKE security associations. Once you move to phase 2, the quick mode, now what you're doing is you're just building on everything that you've that you started here in phase one. All right. Again, the security associations are negotiated. The shared secret key material is determined. An additional difficulty occurs, more key exchanges, and then finally the IPsec keys are produced and generated, and you've got your IPsec security association now is agreed upon, okay, and the IPsec can actually take place. So so there's one thing to remember. Again, I've got these in red for the exam. Phase one is main mode. Phase two is quick mode. In phase one main mode, there are 6 packets exchanged. And in phase two, there are 3 packets exchanged. Okay. If you're, we'll look at there's a tunnel utility that you can actually look at too, and normally I take a look at this when we're doing the Cluster XL stuff, because we'll have SSH, we'll have PuTTY open to the firewalls, and I'll just run a VPN TU. VPN space TU. The TU stands for tunnel util, or tunnel utility, and so the way you work this is that you're trying to build up a tunnel with the other side. It's not working. It's not working. It's not working. So you can run the VPN tunnel util, and it has some options on there that you can disable the IPsec security associations for the peer, or you can disable the IPsec and the IKE security associations for that peer, or you can do it per user, things like that. There's different options. Normally, you think of it just as per the peer. And again, there's questions on the exam that mentions that you've gone into your VPN TU, you've disabled the IPsec security associations. What have you done? And down below, one says you've disabled IPsec, the other one says you've disabled IKE and IPsec, right? Again, it's one of those things you have to read it. There's another question and answer where it looks exactly the same, except instead of disabling the IPsec, you've disabled the IKE and the IPsec security association. So what have you done? And so you pick the answer that says IKE and IPsec security association. Like I say, it's just kind of tricky sometimes with the questions. All right. So again, we're trying to build our tunnel. It's failing. So we're going to run a debug. All right. So on our gateway, we set it up to run a VPN debug. If we're trying to figure out our IKE, we can run VPN debug, IKE on, IKE off. So we'll run our VPN TU. We'll remove all of our security associations that's been established so far. We'll start the VPN debug, IKE on, get the debug running. We'll try to run our connectivity through there, our packets through the tunnel. It'll fail. We'll stop the debug. We'll get it down to our desktop, and there's a tool. It's called an IKEview tool, and if you got that loaded up on your desktop, then you just drag and drop your IKE debug into that tool, and it's very interesting when you look at that, because you'll see all the 6 packets. It'll say phase 1, and it'll have all 6 packets listed there, and it'll have phase 2, and it'll have the 3 packets listed there, and you can just click on each one. And you can see, okay, this is the encryption method you're using. This is the encryption method the peer is using. This is the hash method you're using. This is the hash method they're using. This is the subnet you're using. This is the subnet they're using. So it really makes it. It's just eye-opening what you can see in there, and you can see where the discrepancies are, but between the 2 sides. All right. That's VPN TU. NAT traversal. This caught me by surprise one night. With NAT traversal, like I said, I worked with I was pretty much the SME for our business firewalls. So, and we always set up VPN tunnels for the customers. And like I said, if they were on the eastern half of the United States, we'd set up one tunnel into Virginia, one tunnel into Dallas. They're in the western half, we'd set up a tunnel in Dallas and another tunnel over in San Francisco. So we'd set up 2 tunnels. I'd have all my rules in place before the night that they were going to set it up. And it didn't matter which doorway they came through, you know, east, central, or west, that they could get to whatever server that they needed to get to. So they could just choose their door that they wanted to, because by the time we finished up, but you know, both tunnels would be open and available. So at the first, when I first started out, you know, I didn't really know what I was doing, and I would sit on these bridges, and sometimes, and of course, you know, they're all starting late at night, and if the customer knew what they were doing, if the customer had set up a lot of VPNs, the bridge would open, they'd start the traffic through, bang, there's the tunnel, bang, they're hitting my servers through my business firewalls. Okay, we got that one done, and bang, the second one's done, and you know, and the bridge is closed. But most of the time, it would take hours, and I got to where, and sometimes, you know, there'd be three different tunnels being set up in one night. So I would just tell the guys, okay, I'm not sitting on the bridge line. Everything in the firewall is ready. You know, so you all just test, you set it up. If you got any problems, call me. I'll take a look at the logs. So I did have a firewall, like I say, that set logically between our peer and the customer's peers. And there was just one big rule for the most part, you know, that was important in this policy. It had our peer IPs as the source and the destination. And then when I got the customer IP, I would put that in as the source and the destination. The services were IKE and ESP, and then I also allowed ICMP just so they could test connectivity and stuff. So so they'd set up, that they'd be going, and they would call me. Well, the firewall must be dropping something, David. It's, you know, we just can't get it to encrypt. So I'm thinking, okay, well, you're in there with 200 other customers, just the exact same way. They're all working fine. I don't really think it's the firewall dropping anything. But, of course, I would say, you know, sure, I'll take a look and see. And I would look in the logs, and I'd see some IKE traffic there. I could tell they had connectivity, but there just wasn't any encryption going on. So, sorry, guys, just keep hammering it out. But one night I got a call. And they said, David, we've been working on this for several hours. We just cannot get it to encrypt. I think the firewall's dropping something. Can you take a look at the logs and see? I'm thinking, yeah, right. The firewall's not dropping anything, but I say, sure, I'll take a look at the logs. And so I open, and sure enough, there is a drop on UDP port 4500. In all the tunnels I've set up for all the years I've been doing this, I've never seen a drop on UDP 4500. I think, okay, well, what is this? And so I Google it, and what it talks about is NAT traversal, and it says that they're hiding their peer behind a NAT device, okay? So I get back on the phone and back on the bridge, and I asked the customer, I said, are you NATing your peer IP? Yes, we are. Okay. And so now I have to get verbal approval to make a firewall change, you know, and push the policy. So I get the approval for that. I had a new rule above for our peer IPs and their peer IPs, the source of destination. I'm allowing UDP port 4500 now. And as soon as I push the policy, bang, here comes the encrypted traffic. It goes right through and gets through the firewalls into the servers where it's supposed to go. So that was my learning experience. So then after that, you know, that was part of our questionnaire that we sent out to the customers. Are you NATing your peer IP for the VPN? So one of those things. Again, that's a lot to talk about one of those slides, but that was my learning experience there. Okay, now this is important for the exam. What are the VPN components? And what the question will say is which one is not a VPN component. So it'll have like VPN domain, VPN gateway, VPN trust entities, you know, or community listed. I don't remember exactly which ones, but it'll have these different ones listed, and then it'll have VPN keys or VPN something else. It's not any of these items here. So the answer is the one that's not one of these. All right. So you just want to remember that for the exam. So what is this? Again, this is just terminologies. The VPN community, we talked about meshed or star. The community would be the whole illustration here that we're looking at. All right. The VPN domain is your the domain behind your firewall that you're selecting, that you're allowing other people to come into or people to go out of. All right. Again, this shows it's clear text from the host out to the gateway, but then at the gateway across the internet, it's encrypted traffic. Once you get through that, then whatever server you're accessing over here on this side, it would be clear text, and same way in reversed. All right. So what is your domain? Normally, you're going to set up your domain as subnets. It could be a group of different subnets that you're setting up on your domain. In our instance, it's just going to be your A internal network and your B internal network are going to be your two encryption domains. Normally, our management network, we wouldn't want anybody getting into that. The DMZ probably wouldn't set that up as part of the encryption domain, just because again, that's what the DMZ is for people just to. It's more of an untrusted area, in our internal behind our firewall. So that's the domain. The VPN gateway. There's different terminologies for this. Sometimes you heard me call them peers, VPN endpoints, VPN gateways. So that's just some kind of different terminology. Again, on the exam, it'll be a VPN gateway. The VPN community, the VPN trust entities, that's just talking about, are we using certificates or shared secret for our authentication. The VPN management tool, this is basically just talking about the smart console. You'll do everything just using your smart console to set this up. For site-to-site deployment, communication between offices that are connected by the internet. It says offices. It could be customers out there or whatever. I don't know why on this slide they've got the remote users sitting down here. I don't consider the remote access as part of site-to-site, really. But we've got another slide coming up here with the remote users. But again, normally your site-to-site, you're talking about communication between offices. Two different firewalls. Sorry. Let me get another drink of coffee here. I'm trying to talk faster than my mouth will go. So you've got your two different encryption domains here, and you set that up in gateway to gateway, VPN gateway to gateway. So that's what I think of as a site-to-site development. Oh, ooh. Okay. Site-to-site VPN deployment. Again, just kind of a recap. Certificates, pre-shared secret are your authentication methods. Certificates are considered more secure and are the preferred means of authentication. Again, even when you're exchanging certificates, if you trust the certificate authority there, the certificate has it's called a PKI, a public key infrastructure embedded into that. So even though you're exchanging certificates, you're still exchanging a public key within that certificate. Okay. Pre-shared secrets must be defined for each externally managed VPN gateway. That means somebody else is managing it, which is probably what's going to be most of the time when you're setting it up. So now this talks about remote access VPN deployment. This is our big slide for remote access here. And for mobile users, if you've got, there's client, you can have a client installed on your computer, or it can be clientless. Normally, if you've got a work-issued computer and you're working from home, they've issued you a laptop or something. It's got some type of a, like Cisco AnyConnect, some type of a, Checkpoints is called secure remote client. And so with that client, you open up the client, you go to the gateway that you're to authenticate through, and you use that to authenticate through, and then you're inside the main office. Otherwise, if it's clientless, you'll open up a browser, you'll browse to a web server, and you'll authenticate through there. And in any case, you want this to be secure. Obviously, if you're accessing servers or something inside the internal network, you want this person sitting out here accessing that server to be just as secure as this person sitting in here in their cubicle and accessing it, right? So, So this is going to kind of take us through the VPN communities. That's why we went through this, so you'd see where that information was. And again, when you're setting this up, the participating gateways, you'll hit the plus sign. If bGateway doesn't show up, it just means you haven't enabled that blade on the bGateway object. You just have to enable the IPsec VPN blade there. Okay, and you also have to do that so that you can set up your encryption domain on the bGateway. When planning a topology, your considerations, access privileges assigned to users, the sharing of the internal resources, what type of authentication will be trusted, and the types of network resources available to remote users. So basically, you know, who are we going to allow in? How are they going to authenticate? Once they are in, what are we going to allow them to access? Okay, so we'll talk about meshed and star communities. With a mesh community, the VPN gateways that create the VPN tunnels with all the other VPN gateways in the community. So here, this is the mesh, and then we've got our alpha, our headquarters, and all the other branch offices, and everybody can have encrypted communication with everybody else. So that's in the mesh VPN. In the star VPN, again, you can see why this is called hub and spoke. You've got your central gateway here. They call this alpha out here. You know, I would think of it more as, since alpha is our headquarters, alpha would be the central gateway, and we'd have Bravo and Charlie and Delta, you know, as our branch offices out to it that way. But and we saw how as a default, you know, Bravo and Charlie, we could only have encrypted communication here with the central gateway, but there are other routing options so that Charlie and Bravo can have encrypted communication with each other as long as they go through the central gateway, or that they can go through here and out through other VPNs that they participate in, or out to the internet. And again, this is where in the star community, this is where the VPN routing is, where you would select that. This will be a question on the exam. I don't know why on the slide here they have Alpha and Bravo. When you're actually reading in your student manual, it says the company has corporate offices in 2 countries. And actually, they say London and New York, which are not countries, but they're cities in different countries, I guess. So on the exam, it'll have this will be the London headquarters over on the left-hand side, the New York headquarters on the right-hand side. And London has branch offices here that only need encrypted communication between the satellites and then London headquarters. Same way in New York, it's got satellite offices, but again, they only need encrypted communications between themselves and the New York headquarters. However, we want to set up another VPN community between London and New York. So it says, how do we do that? Well, the answer is just, and it's going to be your longest answer of the 4, because it's going to say, well, first, you'll set up a combination VPN community. You'll set up over here in London, you'll set up a star community between London headquarters and its satellite offices. In New York, you'll set up a star community there between the New York headquarters and its satellite offices, but between London and New York, you'll set up the mesh community there. So here's the access control for the VPN connection. So now we're going to get into where I came into that VPN column. Again, you know, we've been dealing with all these other columns here on our firewall rules. We've just been ignoring the VPN column so far. But if you right click here, you've got the options to select your specific community. With the specific community, that'd be like our Alpha Bravo mesh community that we'll be setting up, or remote access, or you could set up site to site, or you can just leave it as any there. So the any is to allow all connections. So when you think about this now, let's consider that we have set up we have set up an internet between Alpha and Bravo. We've got our A internal network on the Alpha side as the encryption domain. We've got our B internal network over on the Bravo side as that encryption domain. We only have one rule in place: any source, any destination, any service. For any VPN, the action is accept. All right, this is our one and only rule in the security policy. Okay, so say we're going out to say we're going out to msn.com. Okay, we're sitting inside the internal network and we're browsing out to msn.com using HTTP. All right, so it's going to hit our one and only rule. Are we allowed to go out to the internet using HTTP? Yes, we are. So it's going to hit that rule. We're going to go out through the gateway and we're going to go to the MSN website. All right, so there's no encryption involved there. However, if I'm in my A internal network and I'm browsing over to the B internal network using FTP, well now, even though this is just my any rule, it's going to hit my one and only rule here, and it's going to say, oh, you're going from one encryption domain to another encryption domain. You set up a VPN tunnel here, so that traffic will be encrypted. All right. Well, that's what it means by allow all connections clear or encrypted. They allow all site to site. This is all gateway to gateway. That was the second option. And now we've got a branch gateway. Say this is Bravo, and we've got our mesh community, you know, for Bravo to come into Alpha the way we're going to be setting it up. But Bravo is also in several other VPNs. It's allowed in other VPNs. So we would just set it up here for the all gateway to gateway, all site-to-site VPN connections. So now Bravo can go out to any of those destinations as long as it's using FTP. That'll be accepted. The specific VPN community, this is what we'll be doing. And it'll, again, like I say, it'll be our A internal network, the B internal network as a source, A internal network, B internal network as a destination. The service, it'll have you leave it as any, and Alpha will tell you set up as FTP and Bravo. And then the VPN here, the specific VPN community will be your intranet right there. All right. What this is showing here with the remote access community is our remote users can access their emails, I guess, here going to the SMTP server. Okay, any questions about any of those? Again, just holler out as I'm going through these. So now we're back to the mesh community. Remember, with the encrypted traffic, and this is what I do. Instead of putting the rules in, it takes me like 30 seconds to set up my VPN between Alpha and Bravo, because I just come in here instead of having to put the rules in place and everything. I just click this for to accept all encrypted traffic between the domains. Again, the security policy is still going to be enforced. Down here, if you select wire mode, it totally disregards the security policy. The next we click on the encryption. That was the encryption method, the hash methods, and the Diffie-Hellman group, all that kind of stuff. All right. So down here with tunnel management, we've got permanent tunnels and VPN tunnel sharing. Now again, to set this up as permanent tunnels, both sides have to be checkpoint gateways. All right, that's the only way this works. But you can set it up on all the tunnels in the community, just on tunnels of specific gateways, or on specific tunnels that are in the community. All right. For permanent tunnels, I have to talk a lot on these slides. So when we set up when we set up our encryption tunnel, as long as there's traffic going through the tunnel tunnel always stays up. But if a period of time goes by where there is no traffic going through that tunnel, the tunnel will just collapse. All right. Now, when that happens, it doesn't mean, oh no, now we got to get another bridge line. We got to go through, you know, what methods are we using and all the key exchanges and everything. No, it doesn't mean that. It just means that the next time traffic hits that the tunnel's going to be down. It's going to hit it. That the tunnel has to come back up. Now the traffic can go through the encryption tunnel. Again, for us, you know, it doesn't, it'd be the blink of an eye. But when you're measuring time in milliseconds, you know, there is just a slight bit of latency there. All right. So what we can do is we can set up permanent tunnels. And as we're setting up these permanent tunnels, again, both sides have to be checkpoint firewalls. But there's when there is no just normal traffic going through, we can keep the tunnels up by sending out these tunnel test packets is what they're called. All right, Checkpoint has developed these tunnel test packets, and with these tunnel test packets, there's two different types. One is just very simple, just kind of like a ping, and the other one is a little more of a complex packet. So with the packet that's more like the ping, you just got your sending peer and your responding peer, and the sending peer sends out the ping. You know, the tunnel test packet, it hits the other side and it just bounces back. And it's just kind of a lot like the old Pong game. It's just the tunnel test packet. It's just going back and forth and back and forth. And that's enough to keep the tunnel up all the time until actual important traffic goes through the tunnel. The other tunnel test packet is a more complex packet, and the sending peer will send it out. The responding peer then will receive it, and they'll actually send a receipt back that they've received that. So it is a little more complex. The other thing about these with the tunnel test packets is you can make them different sizes. You can experiment on how large of a packet. Well, and again, remember, when we're sending packets through, we're encapsulating these packets, so that is automatically going to make the packet larger than normal, right? So what we don't want to happen is for it to go through the VPN tunnel, go through the internet, hit the other side, and then fragment, to shatter as it hits the other side, right? So we can kind of experiment with that tunnel test packet. We can make it different sizes to see how big we can make it before it fragments. The VPN tunnel sharing, most of the time you're going to set it up per subnet pair. You'll set up a subnet on your side. They'll set up subnets on their side. You just make sure, especially it gets a little more difficult when everybody's using internal IP addressing, you know, RFC 1918 addresses. You want to make sure your subnet isn't 10.1.1.0 and theirs is 10.1.0.0, right? They're using a class B, you're using a class C. There's now your encryption domain is swallowed up. You know, there's an overlapping encryption domain there, so that can cause problems sometimes. So each side will decide on their subnet pairs. You might set up a tunnel for each pair of hosts. So for every connection going that's being set up between the two encryption domains, those are all going to be separate VPN tunnels. Or you might just have one big VPN tunnel per gateway pair, and whatever traffic goes through all shares that same VPN tunnel. If on one side, say we created ours per subnet pair, and the other side set theirs up for each pair of hosts, again, the more restrictive is going to take precedence. So it would actually set up a VPN tunnel for each pair of hosts. This is all we'll take a look at. We'll finally look at our SmartView monitor after we set up our VPN tunnel. It kind of makes it a little bit more fun. And again, to be able to look at the traffic or the system counters, when you click on these, like I say, it's going to say, well, which firewall do you want to look at? A gateway 1, A gateway 2, or B gateway? And if we haven't selected our monitoring blades on those firewalls, on those firewall objects, nothing's going to show up when we take a look at those. So that's why, as we were doing the setting up the compliance view on the SMS, we went ahead and opened up the monitoring on the gateways too. So. Okay, so Lab 6.1 is configuring site-to-site VPN. Just some review questions real quick. Well, what type of VPN deployment handles communication between a network and a remote user? That would be a remote access VPN deployment. Okay. Again, remote access, it can either be using a client or clientless using just a web browser for authentication to an HTTP server. Or HTTPS it would be. What are two different ways to configure rules in the access policy to allow VPN connections? You can have the allow all connections or to allow all site-to-site VPN connections. And again, all these questions are at the end of your chapters. The answers will be at the very end of your student manual. Okay. All right. So now you're going to set up the VPN tunnel. Let me just put some notes here in the. Let's see. Okay, yeah, that's good. Okay, so this starts on page 548. We're moving on down. See, we're in day 3 now. We're, what did I say, 548. Down, 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 down. Oops. So we're going to build a site-to-site VPN between Alpha and Bravo. So the first thing you'll do, you'll open up your A Gateway cluster, and under the network management, this is always under the topology where you set up your VPN domains. So you'll come down here and select a VPN domain. You'll